Hi friends, it's Kamal and you're watching Maths by Jajoria. Please don't forget to subscribe my channel. In this video, I will explain modeling and straight lines, um, length and areas. It's a continuation of my my last videos where I have discussed perpendicular lines, parallel lines, gradients, and so if you haven't watched that, please do so. However, I will leave the link in the description box. So watch that before you continue with this. So let's come back to this one, modeling with straight line, and with that we will go with the length and area. Okay, so you can find the distance between the 2 points. So let's say here we have these 2 points, A and B. By considering the right angle triangle with the hypotenuse AB. This is the hypotenuse AB. Now, those don't really know about hypotenuse. I also have my previous videos on the hypotenuse, and I have discussed in details. However, I will leave that link as well in this description box. Okay, right. So, you can find the distance D, which is this distance D, with the point here x1, y1, and a point here x2, y1 by using the formula. So this is the formula for hypotenuse. Okay, here is D. That's the distance we're saying. And then we need to have this distance, which is x2 minus x1. So that is where we got that square of that one, plus whatever the distance here, y2 minus y1, and that will be the square. So whatever the distance you will have, that will be the square, and then square root of that. Okay, so please remember that. And as I said that if you're not sure about the hypotenuse, please watch my previous videos. Okay, so write down here. So this can be, so you consider here when you solve this. So write down here for you, by considering right angled triangle with hypotenuse, and that is your AB here. Okay, right. Let's move on to some of the examples. So here I have this grid, and some of the example we'll discuss here. So let's say find the distance, and that's between 2 and 3, which is here. 2, and that's the coordinates being given, and 5 and 7. Okay, so these are the coordinates being given to you, right? Now we have drew a sketch. Okay, so let the distance between the point between your, that's the distance between the point, that's your D. Okay, distance between the points. Okay, these are the points here been given to you. Okay, so now as you know, this is your formula. Okay, so that's the you have to find the distance. Yeah, that's the formula we're going to use, right? So I can say, rather than square, so I can say D square as well. So I can start with that D square. Same thing here, because it's just a D here. Okay, so I can say a D square is 5 minus 2, that is square. So what is your here, if you see here, 5 minus 2, so this is your another point, and that's, we are saying here, your x2 minus x1, and that is square. Okay, so the 5 minus 2, and that is square. Okay, plus, and then you have y2 minus y1. Okay, so that would be your what? 7, yeah, minus 3. Okay, and that's square. So don't forget to put the square root. So remember this way, and then you can say, okay, d square, that is your what? 3. That is 3 square, and then what else here? So that is your 4 square. Okay, right? And then you can say, okay, so your d is square root of, okay, and that is what? And that is equal to 5. So, and this is your 5. Okay, so you say, okay, so this d here is your 5 unit. Okay, now the reason I said unit, because it's just a points, so there's nothing in like say centimeter or meters, things like that. So where you have this scenario, then you don't really need to write anything here like centimeter or meter or anything, because it's on the grid. Okay, so that's the option you have. Okay, if there's nothing been given, you just leave like, so you can say, okay, d is equal to 5. Okay, because nothing been given to you, and this is on the grid anyway. Okay, all right, so let's do some of the other example, bit complex one. Okay, exam type question. Okay, so you can get this kind of question in the exam as well. You can carry good marks as well for that. Okay, so here it says the straight line L1 with the equation. So that's the equation of your one line, and there's a straight line L2 with the equation. So remember this one. So you have two equations here. One is L1, L2, and L1 equation is this, and L2 equation is this. Okay, and this intersect at the point A. Okay, so let's work with that. Okay, so for that I have already done this one on the grid, so I will just leave this one here for you. Okay, make easier for you to go through that. I hope it's clear. Okay, right, so here I can just do a little bit here, that as well, where you can see. So it says L1, so this is your L1 here, that's the equation, 4x minus y equal to 0. So that's your L1. Okay, and this passes through your 0, 0, 0 here, that's point as well. Okay, and I also have here for you, so I can say, okay, and that's your L1. Okay, and that is your equal to 4x minus y equal to 0. Okay, and this is your L2 here, 2x plus 3y equal to 21. Okay, so that what here is. Okay, and that is equal to 0. Okay, but however this is your L2, so I can say here L2. Okay, and L2 equation is here, and your L1 equation is here as well. That's your sorry, that's your minus 21 equal to 0. Okay, sorry about this. Okay, so this is a negative sign, negative. Okay, not equal. All right. Okay, now it says intersect at point A. So that is your point A. This is where it intersects. Okay. Now you will also see that I have got here A is equal to 1.5 and 6, and then height is 6 and things like that, because this is I have worked out. However, I will work this out. Okay. Then I will come back to this grid. Okay, and then I say, okay, this is what it is. How do, okay, so the reason I have this part here, I have this here for you. So just as I go through with this question, and I will just explain too. So this is to you as well. So this is your A point. Okay, this is where they intersect. So let's work with this one. What they say, to work out the coordinate of A. So we need to work out this coordinate here. Okay, so how would you do that one? You know already I have worked out here for you. However, I will just go through with you how that happens. So so first we go with okay, here is equation of L1, which is we can say is 4x minus y equal to 0. Okay, so what we need to do with this one, we need to rewrite the equation of L1 in the form. So we have to rewrite this equation L1 in the form. Remember we discussed that in previous video, y equal to mx plus c. Okay, so these forms, y equal to mx plus c, in my last videos, last two videos I should say, I have discussed this in details. Okay, so I'll leave that all the link in the description box as well. Right, so once we do this one, so we know that this will be your y, this equation y. Okay, so that will be y equal to your 4x. Okay, right, so then substitute y 4x, so you need to substitute this. So you got from this equation, that's the L1. So then you write down here, substitute y equal to 4x, yeah, this into the equation for L2. And why we do that is to find the point of intersection. Okay, clear so far? So this was here. So this equation, which is L1, that will go into your L2. So you know what is your L2 here. So L2 is a 2x plus 3y minus 21 equal to 0. Okay, so I write down here for you first 2x plus 3y minus 21 equal to 0. Okay, yes. Okay, so then you got here 2x plus 3. What's your y here? 4x minus 21 equal to 0. Okay, so because we substitute with that, now you have here 2x plus 12x minus 21 equal to 0, and this year what, 14x, okay, minus 21 equal to 0. Then your x is equal to, I can say 14x equal to 21. Then just write down here the space here. Then you got here your x equal to 21 or 14. That will give you 3 over 2. Okay, so 3 over 2 is also 1.5. Okay, however we will just take this first. Okay, so this is what you got, x here. Okay, so remember that. So we go with your x is equal to 3 over 2. Okay, So this is we got. Now substitutes to find the y coordinates of point 8. So point A, sorry. So what you do with this one? So I write down for you here. Substitute to find y coordinate of point A. Okay. So how would you do this one? So for that you have here your y equal to here 4x. Yes. So we'll bring that one here, and that will be your y equal to 4. Okay. What is your x here? Yes, 3/2. Okay. We have that. And that will give us what? Cancel this out. That's 2 here. Cancel it outside. That will give you 6. Okay. So y is your 6. X is your, so x, and you got y here. So point A has coordinates 3, 2, and 6. Okay. So this is 1.5 here. Now, that was the first bit which been asked. Work out the coordinate of A. So therefore, we have the coordinate here. So as I said to you, this is like 1.5 when you further solve that. Now come to here, which I have got this on the grid. So this point here, A, see, I already have this one for you, 1.5, which is, and the 6. Okay, so this is your coordinate you got here. Okay, right. So we can write here as well. Okay, so that will be this here, 1.5 and 6. Okay, clear so far? Okay, so then it says work out the area of the triangle AOB where B is the point where L2 meets the x-axis. Okay, so please concentrate on this one. Okay, let's make understanding of that, what it really is asking. So it says work out the area of the triangle AOB. So here you as you know, that's your A, or this is your O. So B would be this point here. Okay, see what it's asking. Where L2 meets L2. So this is your L2. It says where L2 meets the x-axis. So this is your x-axis. Okay, so that meets here. So in other words, this is your A, O here, and B. So this is your, okay, triangle AOB. So then what is saying? It says the work out the area of the triangle. Okay, so now what we're going to do, we're going to find this area of this triangle, and on the grid here, and that is your area. Okay, I just make a bit of shade here, so that this area shaded. Okay, okay, right. Okay, something like this. Okay, if you want, I can do it here as well. So this area. Okay. Okay, so how we do that? Okay, so let me get leave this one here. Okay, we know the points, and do the rest of the bit back of this page. Okay, by leaving this one here. Okay, like this. All right. So the triangle. So I write down here for you. Okay, so this triangle. So that's second bit B we're doing. So the triangle AOB has a height of 6 units. Okay. How did you get that 6 unit? Okay. The 6 unit here is because, let's concentrate on this one. You see here the point where this intersect is A 1.56. So this is your Y here. Okay. 6 is your Y. So what exactly means? Which means that the Y is this 6. So we can say this height here is 6. So H is 6. Got it? So it has a height of 6 unit. Okay, so you remember that, please. Okay. Now, let's write down here your two equation: 2x plus 3y minus 21 equal to 0. Okay. Now here, I need to write something for you. Okay. Before we solve this equation, it says, so I can say here B is so this point here B. Okay, now we're talking about B here. Okay, remember A or B, this one. So this is your B. So B is the point where the line L2 intersects the x-axis. Okay, at B, the y coordinate is 0 there. So you see, at this intersector here, it's only the x-axis you have. Okay, so however your y here is 0. Okay, so let me write down B is the point. Okay, this is because this is very important, where the line L2. Okay, so I'm talking about this line here, this line L2 intersect the x-axis at B. Okay, that is your B, where the y coordinate. Okay, so y coordinate. So if we say, okay, this is a B, so y coordinate here would be 0. So the y coordinate is 0 here. Okay, therefore your y here, that is, we'll say 0. Okay, so how we will do that? So we'll say 2x plus 3, y is 0, minus 21 equal to 0. So that is your 0. So what you left with, you got here 2x minus 21 equal to, okay, 0, and x would be, take 21 that side, x would be your 21 over 2. Okay, right? So solve the equation to find the x coordinate of point B. Now, so you got your x, you got your y. So now you need to we got the x here, we got 21 by 2. So here you see 21 over 2, that is your 10.5 works. Okay, so that's why I got this one here for you at this point. Okay, 10.5, and your y is 0. Now, as you know, I'm just going to write down here area of the triangle. So what's the formula for that? So that is your half multiply with your B, and base, B is a base, and H is your height. Okay, don't forget that one, base and height. Okay, so the triangle AOB has the base length. So let's write down here what is your base length. Base length, that is the base length of 21 by 2. Okay, so that is your base length. Okay, because this is your base, x-axis is your base, so that's your base length. Okay, 21 over units. So we can say that's units. Okay, but there's nothing. So that's your base, that's your area. Okay, so that is your triangle area, triangle. So I can say triangle AOB area. Okay, so right down here, area would be equal to half. Okay, so your height here, you already know, is 6. Base here is this 21 over 2 multiply height is your 6. Okay, half is 21 by 2 and 6. Okay, 6 your height, base, this is your base. So when you calculate, when you solve this one, that will give you 63 over 2. Okay, now as I said to you that you don't need to give units for the length and the area for this problem, this kind of problem, because you have coordinates, coordinate on the grid, because you have all the things on the grid, so you don't need to write down here centimeter or anything like that. However, so this is your area. Okay, I hope it's clear to you. So let's go back again here with this. Okay, so this is how we found we work it out your height 6, because your 6 here, and that is your y, so the height is your 6 unit, you can say. We also solve this one here as well, your point B here. So A or B, that's B coordinate here. So that was your 10.5. That's your base, and the y is 0 here. And with the help of this, we calculated the area. Okay, I hope it's clear. Okay, right. So let's move on to the next bit now. Okay, so in this this is a new things here. Okay, so it says that two quantities are in the direct proportion when they increase at the same rate. Okay, the graph of this quantity is in the straight line through the origin. So okay, I need to explain to you that what exactly that means. Okay, right. So it's what it says here, that if you have a two quantities, so here you have the two quantities, you have here x. Okay, so you have your x here, and that's you have your y here as well. Okay, so it says are in the direct proportion, like directly proportion. Okay, when they are increased at the same time. So you see here, this is the graph you have. So here your x is here is 1 unit. Now here what it says, if x increases by 1 unit, y increases by k unit. Okay, the not exactly the 1 unit, but it could be any number, but that's why we say it's a k unit. Okay, so let me write down this one for you here. It says if x increases by 1 unit, y increases by k unit. K units. Okay, what exactly mean? So this is what we will discuss here, but this mean the same thing, that y is proportional to, so as y increases, so this line here, so as the y increases, then y is proportional to x. So it's a proportionate thing, directly proportional. Okay, this is what they're trying to say to you. So here we can say here that y is proportional to x. Okay, and we can write like this, proportion to x, y is proportion to x. Okay, then we can say y is equal to k is constant, x, okay, for some real constant k. So I can write down here for some real constant. Okay, right. So this is what when the two quantities. So it's called like modeling with the straight line. Okay, so this is the example of modeling with a straight line. How you can model up with some different types of things. Okay, so let's go with the example. Okay, then you'll understand more about this. Okay, so the example here, it says this graph here. It says the graph shows the extension E. Okay, so the extension your E of the spring when different masses M are attached to the end of the spring. Okay, so it's just one of the example. Calculate the gradient K of the line and write an equation linking E and M. So let's go through with first step by step. Okay, so I will not go into the whole of the questions here. Okay, so here I got mass, or you can say spring, in grams. Okay, in here. Okay, I hope you can see this one. Okay, so mass of spring, grams, and here I got the extension of spring in the centimeter. Okay, and this is the line. Okay, and that is your M. Okay, so let's say it's a slope. First of all, we need to find, because it says calculate the gradient K. So the gradient K we have to find. So in here, use any 2 points on the line to calculate the gradient. So you can say 0, 0 here. So that one you can use 2 point here, 0, 0. Okay, right? And we can also use a 400 here, and you can use 20. Okay, so the 400, and you can use 20 here as well. Okay, 420. Okay, so let's say if we use this one, I'm going to write down this here. So the slope, that's the first, to calculate the gradient of K. So slope is equal to, remember that this is how we used to find slope. For example, the slope like y2 minus y1 and over x2 minus x1. So here, if the points, the 2 points which we're taking here. Okay, so 2 points from here is 0, 0 and 420. So that's 400 I'm taking, and that's I'm taking 20 as well. Okay, so that's 400, and I'm going to take 20 as well. Okay, this line maybe is not okay. Let me just do this line one more time, probably. So that's your 400 if I take, and that's your 20. Okay, so maybe the line should be this way. Okay, so let me just rub this out, otherwise we're not meeting with what we're writing here. Okay, so that should be all right. Okay, so that's you got 400, and that's you got 20. Okay, now it should be okay. Right, so that's the points we got. Okay, so let's go with the slope now. Slope would be what, 20 minus 0, and then we got 400 minus 0. That will give us 20 over 400, and that is your 120. Okay, so that is your K. So we can say, okay, our K, so the K is over, so that is your gradient. Okay, so we got here, calculate the gradient K of the line, and that's done. Okay, then it says write an equation linking E and M. Okay, so that is your M here. Okay, so that's saying that, and this your E here. So that is your linking of that. So we need to write the equation. So as you know, that y is equal to kx. So let's say, and that we got it from here. Okay. Okay, right. y is equal to your kx is the general form of a direct proportion equation. Okay, that's clear. So here is the variation of E and M. So this is the general form. So the variation of then what would be that? Then you can say E equal to Km. Clear? And then you can say, okay, E is equal to your K is 120 and M. So that is your equation for linking E and M. Okay, so this is your E and this is your M, and we got this from the general form. So this is your general form. Okay, okay, so from the general form we got this, right? Then it says explain what the value of K represent in this situation. Okay, so what will be what is actually K is representing here? Okay, so he's just asking that. So you can say that K is the gradient, as you know, and where M value increases by 1 unit. So the M unit here is increased by 1, and the E values increased by E value here increased by K, as from I explained up here. Okay, so you can say the K represent the increase in extension in centimeter when the mass increases by 1 gram. Okay, so you can write down here K that represent. So what is represent? That's increase in extension. Okay, in centimeters. Okay, right, because that is your centimeter here. So the K depends in the extension of the centimeter. Okay, this is what explaining what's the what is represent. So you just need to write down that as well. And where the mass, so this is the mass, where the mass increases by 1 gram. Okay, so where the mass, okay, increases by 1 gram. So that will explain value of y represent in this situation. So this is what you have explained here. Okay, right, so this is more or less for today, and we will continue to work on with other examples. Right, and do me a favor, if you are finding this video informative, please like and subscribe this video, and be sure to click that like button and drop a comment if you have any question, and I will do my best to reply. Okay, thank you for this time.